Hello, everybody. Good day, good afternoon, good evening, and good morning. We're a worldwide global conference. This is the community talk session at YR 2021. And tonight I have Nasser Mooman with us. And just to give Nasser his full slot of the talk, I will just leave the space and let's welcome Nasser and have the talk. The floor is yours.
Thanks a lot. I really appreciate it. Well, thank you everyone for taking the time and joining the session. I appreciate everyone's time. I know it's important. What I would like to do is share some of our experience that we have done here in Waterloo. So the topic is related, how can we really productionize R and R application, in particular using R and R Shiny as a dashboard in enterprise places. So my name is Nasser Mooman. I'm the CTO of the Creato. We are a small company in Waterloo, Ontario, Canada. So we are early stage of health technology company based in Waterloo. Our product, in the time being, it's mainly designing a smart sheet to detect, classify, and alert clinicians and nurses about a status of a patient. In this particular application is pressure ulcer. Pressure ulcer is when there is an infection occurred to the patient while they were sitting on the bed for a long time. So this is a sample of our sheet. Consists of 3 layers, 3 sets. It consists of more than 1,400 sensors, like pressure sensors, temperature sensors, and humidity sensors, as well as we conduct gyroscope. The idea actually is based on the sensors, we try to collect data, and then we try to get an insight of the data. In particular, all those sensors that we collect, we could classify, or we could get an image of a person on the bed without having a camera inside the hospital room, which is against the HIPAA. And based on the sensors and the data we collect, we could create some insight. One of them actually predicting the posture of the patient, the humidity, mobility, whether the patient on the bed and off the bed. So our design, our system is already Health Canada approved, FDA approved. It fits any kind of mattresses. It's based on wireless or Bluetooth between the smart sheet and the system data. So the whole scope of it related to Creato is we use Azure as Microsoft is one of our partners. We use our own. However, some of the health facilities, they are not really, they have their own platform that sometimes is not Azure based. Some of them, they have their own. Some of them, they have different third party. In that case, we have to provide our own way of, SSD, which is, software as services. So we create our own dashboard for our potential customers. Our data could be API to their platform, or could be standalone, or could be hybrid. So the idea actually is we have a bed or smart sheet that a person lay down on it. We collect the data in real time, almost near real time. We could have 3 seconds, 4 seconds. It's customizable. In this case, it's every 3 minutes based on the feedback from the nurses and the health center. And we'll collect the data in real time. Could be the server on-site, could be hybrid, some of on-site, some of in the cloud, or could be any particular facilities. And then based on the data we collect, we kind of get some insight, classification, alerting. We apply AI model at different level to share the finding with the clinicians, with the nurses, with the caregivers. So the application could be at hospitals, nursing facilities, and home health. So these are the information that we collected. So this is representation of images that are collected from the sensors. The application we could have is pressure injuries, incontinent, acute heart failure on the bed, off the bed, burns, and so on and so forth. So these are some of the insight that we collect in real time based on sensors. So we're collecting on the detecting heat, detecting mobility, if the person mobile, not mobile, posture detection, humidity, and then we could really tell and alert the nurses whether a patient on the bed or off the bed. So such information, we want to present it in a nicer, easy way into the end users. So what we did actually is, this is a sample of our dashboard for the end user. As you could see, we tried to make it elegant, make it easy. As you know, nurses have so many tools and screens, so we make it much easier for them to see the information without having them to interact with it. In the case of burden or adding more stress or extra work into the nurses. So this one, it shows, for example, on the ranking, that particular mini PC ID, okay, at what level, like, you know, we measure incontinent detection, dry or wetness, the time has been wetness, and repository information that the nurses find very useful. So what we try to do is this one done by Shiny R in particular, make it easy, elegant, clear the message without overwhelming the nurses and overwhelming the dashboard design. This is another, so there's two end users. We have normal nurses or caregivers and some we call, you know, analytics, people who want to define more, understand the data in depth, analyzing it. So our dashboard, which is totally done with R and R Shiny, and this one semantic, Shiny semantic. So as you could see, it cleared the representation of what's occurring on the bed. On the left side, it shows the pressure and the humidity and temperature. These are some of the chart line representation of pressure, temperature in real time. So how can we deploy such application into a health facility or into the client using our enterprise? So there's two important scope of when you decide to use our Shiny or dashboard for an Azure enterprise or production one. One more, understand your client, understand your environment, and most importantly, where is your data bottleneck? Are you gonna use end user IO, a lot of activity, or we gonna use just passive information that the user could, you know, consume? So what we did, we split the dashboard between the user who only need to read the information and user who could be to analyst. So we could have a dashboard in this one could analyze the data, look at, you know, the chart, go historical, and so on and so forth. So why dashboard is important to, you know, to in business? As you all know, of course, it has to be, of course, you know, simple, much easy, enable to get information in real time, access from any device, mobile or any, you know, any other devices. You could customize it, you could share it at any time. Less expensive, live interactive. Sometimes you need an interactive dashboard. Avoid data overload. That is really essential, and easy to have a KPI, which is really a representation of, you know, the performance of your analytical information. So, but with that, in order to deploy any product, in particular dashboard or web application, into an enterprise level, there is a set of requirements that has to meet. There's no really sequence in this perspective, but important points that you have to consider. Because just development and easy prototype or a simple R&D application is different than a production enterprise level. So most importantly is the security, where your dashboard, where your server, where your application resides, within the hospitals or in the cloud. So this is very important to have a secure application. A scalability can be scaled. Can you add it? Can you add more users, more application, more features into it? And then most importantly, the latency, the timing is delayed or not. Easy to upgrade. So change control is very essential. Centralization management. It has to be DevOps or MLOps friendly. So it could be continuous integration, continuous deployment, continuous, you know, testing. So can you update the application or your AI model and then deploy it without interruption of production? On demand, of course, has to be on demand, especially in this case, very critical application and critical user, which is hospitals and nurses. Maintainability can be maintained, right? Do you have a log? It can be really do the upgrade without interruption to the end user. The reliability and robustness. So if there's any fault or hardware failure, do you have a backup for that? Do you have other fault tolerance where the server is always going to be available? So these are sets of features that it has to meet a product, a web application, to count it or rank it as an enterprise. So the solution, I think this is it's common. Some of you maybe know already about it, but we tested, we evaluated. So it consists of, these are the components. One, we're using Docker. We know Shiny or R itself, it's not really meant to concurrent users or parallel users because of the overload. You could go and get RStudio Connect, which is an enterprise product, and then you could pay for it, and then you have it your product as an enterprise. If you have a challenge in the scope of cost and hiring multiple end users like UX and full stack and back-end developers, and especially in our case, we're a small company, if the budget is one particular challenge, can you do something with R, because R have a lot of features, like China in particular, and make it an enterprise level? So these are the core components in which you could use to bring an R application, in particular Shiny, into an enterprise and production level. One is you could use, I think you use Docker. Docker is kind of a tool that it's used in the market. That's where you could containerize your application. You could do Google that as well. Docker is different than virtual system because you could utilizing the same server, it's utilizing the same OS. The only thing you have to do actually virtual application. And you could do, one thing you could do is called ShinyProxy. That's a really cool product that allows you to productionize your product with Docker. So in that case, it allows you to packaging the R with the ShinyProxy and deploy it through Docker. Of course, you have R and RStudio as a tool product, but R application as well. And then you could have third party on other applications like C and Python and C++ and other applications. Now the OS, it could be Linux, Windows, AWS or Google or Azure, any platform. Having those major 4 components, you could, I put some links at the end of it so you could go and dig into some search about it. That allows you to compose a full dashboard at an enterprise level. And most importantly, I give credit to the team from Golem and Epsilon. So we have, for example, R, in particular, we use Golem. Golem actually, as of bringing product into production, it has to have a standard, like the folder standard structure, the testing, unit testing it. You have to have kind of where you keep your description, your documentation, your R code, third party, if you're going to add HTML or CSS or JavaScript. So Golem, they have done excellent job to standardize R or R Shiny project where the folder is being structured in a nicer way. And then I will go over some of the features that Golem use. So we use Golem because every time you hire a new developer, they have their own standard, and you try to keep the same standard. But having Golem, I think we all could stick with standardize your application, your project structure. And then we use Shiny or Shiny Semantic. It's more faster, more robust, make the GUI and the icon more elegant. You could tap it as well. So you could have Docker, as you might maybe do some research about it, Docker architecture, the open source, of course, allow application to be packaged into a containerization. So that's enable developer to package the application to a container, standardized executable component as well. It's a platform used to containerize our software without really having a new virtual server. Okay. So Docker, of course, you have could be on your Windows or called Linux. You have a client and you have the host and the register it. That every time you create a new one, you compile new Docker, you come a new image, and the image will execute and create new containers whenever needed. So some of the advantages of Dockers, I just had them here in particular. You could bundle the R package into a Docker image, and then this is where you allow concurrent user. That's where, different from the Shiny server, where you have multiple users in the same time accessing and using your application. And this is every time a user use your, the image, every time you an application, a new session or container spins out as a session. And that's exactly allow multiple users concurrently using the application without burdening it on your dashboard. Without Docker and ShinyProxy, the limit of number of users at the same time, where the dashboard will be limited, and then the latency will be very slow, and then that is really not very, the rendering of the image becomes very, very bad quality. Okay, so every particular workspace is unique for each session, plug and play, and control memory usage, monitoring and debugging the standard Docker tooling. Okay, so these are ShinyProxy architecture. You could have a server, any server you have a Docker, you have ShinyProxy, and you add the Shiny application to it. So in this way, you have every particular Shiny application has become a spin out Docker or container by itself. Another feature you could use, we call it Dockerizing. Dockerizing actually is, instead of every time you want to deploy a new Shiny, you have to recompile everything. Dockerization, where you could Docker ShinyProxy as it is. Every time when you want to deploy a new application or Shiny application, as long as it's an application.yml, you don't have to really compile the ShinyProxy one more time. So it's very easy. Make things much clearer actually.
Okay.
Yeah. So any question? Yeah.
No, sorry. Go for it.
One thing lesson learned. So what you could do actually is, as you have your Shiny and you have dashboard, always you're going to have, of course, data source. How could you really access the data source? One thing you shouldn't really, we'll recommend it that you put the data within your project. So you could really, what you could do, and Docker allows you to do, is you could link your data from the host machine or the host system into your Shiny. So the Shiny application could access to the data that's on your host machine. There's two options. You could have it like we call, I mentioned in here, we call it, bin mount or volume. Bin mount actually is a file system that you link to it, which is not very good. Volume allows you, has some features where you could allow you to back up your data. Every time when you mount a file system, it will not add the size into your Docker container there. So here are some of the features. Use volume for persistent data, generating, and then volume better because the volume does not increase your size of the container using it. And then easy to manage and easy to back up. So these are the structure where you could have multiple Dockers, where you could have access to the data outside of Docker.
Okay, thanks, Nasser. We will need to go to the conclusions.
Okay. Okay, so yeah, okay, so I think I'm about, thanks a lot, everybody. So Golem has a feature as well. So Golem, what we use, here's some of the Golem, this is a tool simplifying the creation of development application. So standardizing your R structure, unit testing it, has module in it, deploy to RStudio, Docker, ShinyProxy, and Heroku. So we have tried Dash, Python, we try Azure, we try React with the features of Shiny and R in particular, where you do data analysis, data science, and Shiny. It was very elegant outcome. You don't need a full developers at the UX and backstack and backend. So we were able to connect and present the data to the end user in an easy, simplest way, and then easy to develop without really having a high cost of performance. So these are the applications that I want to share with the community, and I have some references to the community that they contributed. I appreciate everybody's effort. So I think the answer is yes, you could deploy R and R application, in particular Shiny dashboard, into production as long as you do your homework. Most importantly, you have to have a system engineer, understand your client, include the client in your design, and then of course it has to be secure, and it has to be scalable, and it has to be maintainable, where you could check the logs and so on. So appreciate everybody's time. Thanks a lot. I hope this was informative and useful for everybody else. You could give it a try. Feel free to contact me for any further information. I'll be glad to assist you and share my experience with the team.
Okay. Thank you, Nasser, for your time and for the presentation. I think we need to wrap up and go to the next presentation.